Computational fluid dynamics analysis for enhancing the performance of drone frames. Selection of drone frame, propeller, motor, and other avionics. Abstract: drone is a profoundly progressed flexibility airplane that has a basic plan and construction. It has a high burden conveying limit and different qualities. Robot is one of the UAV, Unmanned Aerial Vehicle, which is utilized to lift, convey, notice, salvage, and gather information starting with one spot then onto the next in lesser time and without taking a lot of room and cost. Drones are classed at first according to their anatomy, operations, size, and weight. They are further categorized based on variables such as the number of rotors utilized, the position and orientation of the rotors, and the design of the frame. With the smallest size possible, the payloads of different drones, Monocopter, tricopter, quadcopter, and hexacopter, will be changed by changing the design, aerodynamics, structural weight, etc. of a particular drone. In case the drone type and size are not specific, the same can be done by increasing the number of rotors. The payload increases with the increasing number of rotors at the expense of the size and structural weight of the drone. The structural weight will be reduced by opting for any low-weight material and changing the design, or even size. This reduced weight will be added to the payload as increased efficiency. The possible material could be aluminum, but because carbon fiber has a lighter weight than aluminum, we opted for carbon fiber. Moreover, carbon fiber has exceptional strength and rigidity and has a specific tensile strength of approximately 3.8 times that of aluminum and specific stiffness of 1.71 times that of aluminum. We will be describing and discussing the design of different drone frames, i.e., monocopter, tricopter, quadcopter, and hexacopter. Firstly, we'll design the structure of a drone with dimensions and then analyze the frame, selecting the necessary material and structure that meets the weight, strength, and stiffness of the requirement of the system. Also, we'll be analyzing these drone frames using different software. Keyword: aluminum, analysis, carbon fiber, design, frames, multi-rotor, payload. 1. Introduction. An unmanned aerial vehicle, UAV, is an aircraft without a pilot or passengers on board. UAVs include both autonomously controlled vehicles, drones, and remotely operated vehicles, RPVs, controlled via radio transmitters. Drones are often employed in situations where the danger of dispatching human-piloted aircraft is high or when the utilization of manned aircraft is impractical. One in every one of the essential exercises of the UAV was the aeronautical torpedo, planned and worked during essential fighting. Multi-engine drones are gaining popularity among us thanks to their wide selection of applications and structural integrity with perfect stability. Drone may be an UAV that may perform multiple missions. Recently, there's increasing interest in drone applications like surveillance, search and rescue and object detection to parcel delivery thanks to its high mobility because it can hover, take off, navigate and land in tight areas. Factors like size, range, capabilities, weight classify drones into different categories. After we associate with aerial platforms, drones are available in 4 types: single propeller, multi-rotor, fixed blade and fixed wing hybrid. This review focuses on the look and analysis of drone frames which will support payloads as high as 5 kilograms. The sunshine weight and high thrust capacity of the Turnigy 4245 30 kV motor allow it to extend its lifting capacity, which is able to be higher with electronics and electronic components when placed thereon to control. Structural analysis is one of the important applications of the finite element method. The drone's motor and propeller are selected per the necessities of the drone's chassis. The planning and assembly of the chassis of the monocopter, tricopter, quadcopter, and hexacopter was dispensed within the Kasha V5 design software. The elements are finished by learning the texture properties of each casing, the strength of the fuselage and hence the inflexibility of the robot outline is investigated to help the computation of the extent of the push created by each engine. The 15 x 5.5 propeller and also the 530 kVA engines were accustomed to analyze the thrust of every engine. This push is employed to see the structural analysis of varied drone frames. 2. Methodology. Design of drones. First, we'd like to spot many materials like components, avionics, and electronics-related variables that contribute to the mechanical and physical properties of the drone. Second, appropriate physical and mathematical models describe how the characteristics of the individual components of the drone are often combined to supply the properties of the fabric itself. It's, therefore, possible to style a drone specified the specified properties for a specific application. These properties may simply be having a specified hardness and strength, a desired thermal conductivity, or a specified minimum hardness at the most affordable possible cost per unit volume. Notwithstanding the determinations, one can plan a particular robot. We must also note that there is also a high payload drone that's more suitable for the applying than our designed high payload drone. Our engineered drone must therefore offer a selected cost or performance advantage over conventional alternatives. One amongst the needs of this resource is to indicate to you the logical steps required to travel through the planning process. Approach methodology. 3. 3D prints and Kasha designs. 3D printed parts. We took 3D print extra components so that we may have spares in the case of an accident, notably additional landing gears. Because most of the components serve two roles and are not flat on both sides, certain components will require support material to print. To conserve weight, we chose an infill of 20 to 30%, which produced excellent results. Kasha designs. The drone frames are planned utilizing Kasha planning programming. Kasha software. Kasha represents computer-aided three-dimensional interactive application. It is an arranging programming made by Dassault Systems. It is basically used for arranging, by various controls like aeronautical planning, mechanical planning, civil planning, architecture, electrical planning, and some more. Numerous workbenches are accessible which can be utilized according to the necessity, similar to part design, surface plan, sheet metal plan and some more. The planned segment would then be able to be moved to different investigation programming by changing them over to various configurations like STP, IGS, and so forth. For the undertaking, wireframe and surface workbench was utilized. A 2D sketch was drawn utilizing Sketcher, at that point changed over to surface in the wireframe and surface workbench. Frames. Features of designed drones. Maximum vibration isolation, easier on the flight controller, smoother video, noise reduction, electronic longevity. Lightweight design, weight centralization, maximum payload, increased battery life, overall efficiency. Structural rigidity, strong airframe, but not overbuilt were unnecessary. Integrate or combine as many parts as possible, perfection by simplicity, reduced part count, function over form. Modularity and compatibility, i.e., hackable, dimensions bolt up to other common parts and accessories. For weight and rigidity, carbon fiber tubes are used for drone arms and legs. For analysis and results. A monocopter. In monocopter, one rotor is found inside. Another will be a rotor that essentially assists with making control to the heading. Monocopter may be the best decision for a speedier flight time with longer constancy alongside a mix of float having heavy weights. Mono-wing rotorcrafts are outfitted with framework and control actuators so they'll turn themselves and head to any ideal bearing. Monocopter is advantageous to produce and keep up on account of the direct and compact design. The highlights of rotorcraft in do itself the adaptability to in an upward direction start and land, and in this manner, the drifting soundness permits it to work inside the bound climate. Since monocopters are generally conveyed in reconnaissance missions, the deception of the airplane is significant. The essential design of a high payload limit monocopter comprises of 3 sections, a mono-wing and 2 aeronautics bars which are connected by an inflexible pivot, appeared previously. Engines are set at the tip of flight bars and payloads are organized on the flying bars, so the center of mass for the total airplane may be made inside the space between the flying bars. Engines apply force to pivot the airplane, then, the turning monowing gives lift power to the airplane. During a standard flight, the monocopter turns round the focal point of mass. Mathematical model. Blade element aerodynamics. Above fig shows the inflow sketch at a delegate edge component on the single wing. At the point when the vehicle is turning at a pace of O equals PQRT, the neighborhood translational speed of the edge component can be portrayed as, where lb is the edge component's range vector and lb equals lb 0, 0 in the body fixed casing T, VCM is the vehicle's focal point of mass's translational speed, and VCM equals UVW. According to the relative movement theory, the sharp edge component's inflow speed is, where Wi is the computed induced velocity using momentum theory. It is provided by whilst hovering. Because the effect of radial component, UR, on the lift is always ignored, the resultant inflow velocity is, therefore, B. Tricopter. In a tricopter, there are 3 various types of incredible engines, 3 regulators, 4 gyros, and just 1 servo. The engines are just positioned at each outrageous finish of 3 arms, and each one among these is holding an area sensor. To lift a tricopter, the choke switch is started first, then the gyro sensor gets its flag and can give the sign to the regulator that assists with dealing with the engine pivot. A tricopter is prepared to stay settled on its way since it is furnished with a great deal of exemplary sensors and hardware itself. No manual remedy is needed to be applied. Tri-rotor UAVs are regarded to be unbending items when the elements of tri-rotor UAVs are compared to the climate. For tri-rotor UAVs, the 6-degree opportunity, DOF, nonlinear movement conditions that are created for regular UAVs are used. The tri-rotor UAV is unable to turn and decode in 3-dimensional space, and Newton's principles are used to infer the inflexible body components. The 6-DOF unbending body conditions of movement for tri-rotor UAVs are conveyed based on the differential circumstances depicting translational movement, rotational movement, and kinematics as shown in Fig. Where Fx, Phi, Fz are the outside powers, and L, M, N, are the outer minutes following up on the focal point of gravity concerning the body fixed edge. U, V, W, are the translational speeds, P, Q, R, are the rotational speeds, and, are the rotational points. Is, EI, and Is are the rotational inactivities of the tri-rotor UAV. Mathematical model. The chart above depicts the tricopter's unique situation, with the powerful condition of yaw control outlined on the lower right side. This is because the RC servomotor operates the tail pivot to modify the declination point of the tail hub in yaw control. The movement control of the tri-rotor may be broken down into height, move, pitch, and yaw. The control techniques for tri-rotors are shown in Fig. Tri-rotor control systems. The elevation control is shown in Fig. A, and increasing the speed of each rotor increases the height, and vice versa. The mechanism for move control is that with a comparable rotor 1 speed, adjusting the rotor velocities of the 2 front rotors creates move control, see Fig B. Pitch control is seen in Fig. C, with identical rakish speeds for the front 2 rotors, changing the rotor speed of rotor 1 produces pitch control. Yaw control may be successfully established by employing the characteristic yawing second from the reaction force and also from the slant point. The slant point is especially useful when there is a sudden risk of collision since it allows for unexpected turning control by changing the rotor. Simulation in Matlab for position determination. Plotting 3-dimensional locations against time outline in Matlab reveals the relationship or dependency of location on the brisk speed of engine/s. The plot of location vs time is captured on the screen in figure. Absolute speed is predictable when speed augmentation is 0. It's necessary to unravel an assessment between the tri-attempting copter's speed and also the prompt speed in order to figure out the condition of the tricopter with time inside a reach. Careful speed is steady when speed addition is 0. The SASI speed is 50 as the speed addition is 0 in the redirection result. Despite the fact that the happy speed is also 70, increase the pace. When the SASI speed is 100, speed augmentation may be 0 at that moment. When speed augmentation is 0, the value of demanding speed is 150. Finally, the particular speed looks to be 200. With the aid of Matlab, these results demonstrate 3D position. CASE1. Angular velocity is constant, and acceleration is 0. C. Quadcopter. A quadcopter is a multi-rotor aircraft with 4 rotors that lift and maneuvers it. It is also known as a quad-rotor helicopter or quadrotor. Quadcopters are rotorcraft, not fixed-wing planes, because they are propelled by a swarm of rotors, in a vertical bearing arranged propellers. Bundling on quadcopters may be classified into 2 categories based on their design, profiled edge and X bundling. In a profiled arrangement, the space is more visible, and the point of gravity connection is more difficult to locate. It can keep the machine arm and mount in place, giving you more time to concentrate on post-processing modifications. It takes up relatively little room when deflated and is easy to pass on. It might be used to hold apertures for the installation of ultrasonic modules. The X package is easier to set up, has a higher value, is more versatile, and is more practical for stunt flying. We used 8 iterations for all estimations. We assume inlet velocity 130 m/s, then by estimate the effect of the inlet velocity we get the shown in scaled residuals graph. The influence of the force on the plane's surface was investigated in order to verify that the plane's capacity to handle the weights that would be on it and that the design will be able to maintain its shape without deformations. For this, we estimate that the force acting on the quadcopter's top surface will be 1 n. The maximum total deformation was found to be 0.00096759 mm, the maximum elastic strain was found to be 0.001151 mm/mm, and the maximum stress was determined to be 1.1498 MPa. The frame is made of carbon fiber, which has the following properties: elastic modulus E equals 2.3 E11 Pa, Poisson's ratio equals 0.3, and density 1.5 E3 kg/m. To reduce high-frequency vibration disturbance during descent, a quadcopter should be used. We recommend the following 2 responses in this respect. 1. Reduce the rate at which loading and unloading equipment is used, and finish loading and unloading in a quasi-static condition. 2. Vibration isolation equipment with higher high-frequency filtering capability can be installed on the frame. Design summary. This design uses */E programming for the chassis demonstration plan and AutoCAD to complete the 2-dimensional assembly drawing and parts plan. It increases standard plan interaction, competency, and reduces fabrication costs. To meet the look requirements, we must consider the resultant requirements and each aspect, as well as support the many situations and circumstances of using outline. Break down the edges assortments of add the exact workplace first, then construct a 3-dimensional model of the casing using PRO's 3-dimensional showing programming. Second, select authorized materials to reduce prices and the casing's heap. Third, finish the limited component model by measuring the calculation model and lattice appropriately using limited component programming. Fourth, import the restricted component model into ANSI to determine and break down the casing's strength and solidity. Fifth, read the results and enhance a section of the structure, upholding the results of the static examination so that we may enhance proficiency, primary strength, and texture firmness. We can get a wide range of nitty-gritty anxiety shapes, modular examination arrangement graphs, and comparing information by dissecting the edge of the quadcopter with the 3D limited component to manage the advancement of plan and decrease the costs of configuration, plan, and investigation process duration, and thus the utilization of crude materials and capital, which is unfathomably advantageous. D. Hexacopter. A hexacopter fills in whatever number possible applications as could be expected under the circumstances with its 6-engine system where 3 works the clockwise way and the other 3 moves the counter-clockwise way. Subsequently, hexacopter can acquire higher lifting power when contrasted with quadcopters. A hexacopter is intended to fill in as an amazingly protected landing crate regardless of having an intricate plan and system. Hexacopter configuration. In a hexacopter, 6 motors drive 6 propellers. This hexacopter lifting increase uses the momentum transmitted by the propeller mix of hexacopter charts. The package design is separated into 2 categories, as illustrated in Fig. Plus, and X. The 6 degrees of freedom, DOF, of the hexacopter are influenced by the rotational speed of each rotor, hence, the 2 lodgings will have verifiable improvement component models. In this assessment, the plus outline chart is used. Each arm has a brushless DC motor and a fixed pitch propeller, which allows the rotor to drive the wind current downwards to create T. Each arm is powered by a brushless DC motor with a fixed pitch propeller, which allows the rotor to direct wind current downward to create lift force. The rotor rotation direction is made up of 3 counterclockwise rotors, CCW, and 3 undeniable clockwise rotors, clockwise, CW. From an overall perspective, it is evident that the hexacopter's unfathomable headway is only determined by the speed of the engine rotation. The package should be made of lightweight materials that are capable of supporting its operational and vital weights. As a result, inspecting the adaptability and strength of the creating material out of the edge is crucial. As shown in figure, heavy lift hexacopter schematic plan, this edge is arranged as a hexagram with 6 equivalent long arms attached to the point of convergence of a replicated hexagonal plate. Analysis of hexacopter frames. Thrust and motors. As the drive component for the hexacopter, the engine is the main segment. In any case, prior to deciding the limit of the engine applied in the plan, it is important to know the all-out weight that will be lifted and the push which is needed to lift the substantial heap of hexacopter. The estimation to decide the push per engine as in the accompanying condition. In addition, static push can be determined by the accompanying condition. In this situation, T represents the engine power, while D represents the propeller diameter, is the air thickness, and P represents the propeller diameter. This calculation will be used in combination with the following figures. The propeller predictable is Kp, the distance across is d, and the engine rotational speed is rpm. The kV constant and the voltage utilized by the engine are utilized to compute the value of this rpm. As the primary source of power in the hexacopter construction, a BLDC engine is used, which has the advantage of not requiring a brush or commutator. As a result, this type of engine will be more valuable than a DC engine. High RPM may be passed on by a BLDC engine, revolutions consistently. kV, RPM/volt, where kV is a cutoff that indicates the amount of RPM increase for each unit of voltage employed, is the most crucial pressure of a BLDC engine. Frame. The packaging should be worked from lightweight material yet adequately ready to help its operational weight and essential weight. From this time forward, it's critical to investigate the flexibility and strength of the making material out of the edge. The energy of this edge is hexagram with 6 identical long arms that attach to the focal point of a duplicated hexagonal plate of as exhibited in Fig. Frame and fragment. E weight of each component of drones. F results summary. With the replacement of aluminum with carbon fiber, we got a reduction in structural weight by nearly 42%. That reduced structural weight got added in the payload as increased efficiency. Also, the designs we opted for helped us increase the efficiency of our drones. In Monocopter, by using the aluminum the frame weight was estimated to be 775 gm. By replacing the material with carbon fiber, we got a weight of 450 gm. Thus, with the replacement of aluminum with carbon fiber, we got a reduction in structural weight by 325 gm. In tricopter, by using the aluminum the frame weight was estimated to be 760 gm. By replacing the material with carbon fiber, we got a weight of 440 gm. Thus, with the replacement of aluminum with carbon fiber we got a reduction in structural weight by 320 gm. In quadcopter, By using the aluminum, the frame weight was estimated to be 1120 gm. By replacing the material with carbon fiber, we got a weight of 650 gm. Thus, with the replacement of aluminum with carbon fiber, we got a reduction in structural weight by 470 gm. In Hexacopter, by using the aluminum, the frame weight was estimated to be 1690 gm. By replacing the material with carbon fiber, we got a weight of 980 gm. Thus, with the replacement of aluminum with carbon fiber, we got a reduction in structural weight by 710 gm. 5. Conclusion. This exploration has been empowered to style, dissect, and develop substantial lift monocopter, tricopter, quadcopter, and hexacopter that is equipped for flying and lifting the payload. Appropriately, with the reduction in hidden weight and with right size and style, more payload was passed on by these multi-copters correspondingly. The results are given by the result fragment game plan of the ANSA workbench. Here the determined outcome from the appropriate response is imported for the post-preparing of the undertaking study. Shapes of shifted boundaries of the stream will be acquired and dissected to check the conduct of the stream. Different instruments like vectors, smooth out will be utilized to consider the bearing of the stream and different boundaries. Future trends. Armed with a good range of benefits, drones have a key role to play within the growing market in India. Drones have made an entry into diverse end-user segments, and therefore the developmental efforts for locating newer drones for existing and novel applications are a part of top priority. The new drone could likewise be liked for a few reasons, such are more grounded, lighter, or more affordable contrasted with conventional materials. Progressed drones are, generally utilized in space innovation applications, are a piece of main concern. The new robot could likewise be liked for a few reasons, such are more grounded, lighter, or more affordable contrasted with conventional materials. Progressed drones are, generally utilized in space innovation.